we can multiply complex numbers in polar form using a particular rule. Um, and this rule is listed at the top of your screen. A times cosine x plus I sine x is going to be our first complex number in polar form. And this is our second complex number in polar form, so it has a magnitude, and the angle in cosine and I sine are the same. And what you see over here is we have a times b, so that's multiplying the magnitudes, and cosine of x plus y plus I sine of x plus y. The easier way to remember this is you can multiply two complex numbers by multiplying their magnitudes, so a times b, and adding their angles. So x plus y ended up being the angle in our result. So let's prove this claim. So by the commutative property, I can rewrite this as a times b all at the front of the expression, a times b, and then we have cosine x plus I sine x times cosine y plus I sine y. Now we're going to use multiplication. So distribute these. Cosine times cosine, cosine x, cosine y, cosine times I sine becomes I cosine x sine y, I sine x times cosine y becomes I sine x cosine y, and I sine x times I sine y. I times I becomes -1, and then sine x times sine y. Now you'll notice that two of these parts are real, and I'll combine those together. Cosine x cosine y minus sine x sine y plus, and these two parts are imaginary, I times cosine x sine y plus sine x cosine y. Now, if you remember back to Unit 5, these were some of our formulas. These were our angle sum formulas for sine and cosine. So this is AB. This whole thing, if you look on your reference sheet, this is cosine of x plus y. And if you look on your reference sheet, this whole thing is sine of x plus y. Therefore, we have that we can add the angles and multiply the product, multiply the magnitudes. A particular corollary from this is called de Moivre's theorem. It's a French name, de Moivre. De Moivre's theorem states that if we take a polar form number and raise it to the nth power, we can multiply n times each of the angles as well. And the proof is exactly the same as before, but we'll use that soon when we're trying to find square roots or cube roots or fourth roots of complex numbers. Thanks.